Right, we are nearly there. We are very near the end here. This is the question 7. So if you've skipped to this, I'm disappointed, but if you watched it all, well done. 7A, part 1. Now, it's got a diagram, which I'm going to draw here. This is about optics, this question. If you haven't done optics, you can go back and look at one of the many videos I've done. So it's the normal, just put N, light rays going in, at 42 degrees to the horizontal, and it's refracting, whatever you want to call it, at 27 degrees, and it's hitting point P, which is this point here. And it says 7A, complete figure 8 shape the light beyond P until it turns to air. Now, for it to it's going to totally internally reflect, but for it to totally internally reflect, it's to have a large angle in critical when it hits a boundary, and it's got to have be surrounded by a material of a lower refractive index, which this is glass and air, and this is just a liquid, which we assume to be of a lower refractive index. So it is going to totally internally reflect as far as we're concerned. So it's going to bounce back off P, and then it's going to go there. And now, because this is the normal still, if it's going into a less refractive substance, it bends away from the normal. But if it's going into a high refractive, it slows down by more. So it's going to bend away from the normal. Let's get rid of that air word. So that's your 7A answer. So it shows that a refractive index of glass is about 1.5. Now, using a derivation of Snell's law, this is 7B by the way, we can know the instant angle. So I equals 42 degrees, and R is equal to 27 degrees, N equals sine I over sine R. Now we know if we've got this right, because this should come out to be 1.5. So N equal to sine I, or sine 42 degrees. Don't forget the sine bit, or sine of 27. And that should come out, put it in the calculator. Yep, to 1.5-ish. We rounded it up. So that's refractive, and we've shown it. Now we know it's right because it's come out as 1.5 degrees, 1.5 ratio of refractive index. There's no units because it's just a ratio of the speed of light in one substance to the speed of light in another substance. It says calculate the angle for the glass liquid boundary. So, does it say what the refractive index of? Do you know? So, let's see what it's got here. It's only worth 1 mark. That's weird. Sorry, just give me a second. We know it's going to be less than 63 degrees, so just put less than 63 degrees, and you get a mark for that. Critical. I'm not sure how it came up with that, but hopefully you will. So that's not really good doing a tutorial where you're expected to know it. So it says calculate the refractive index of the liquid. Sorry, just let me do this. So refractive index is Sin I over sin R, or n1 over n2. Yeah, so critical angle, what was it? Asking for the fractive index. So sin I over sin R, 7D. So n is equal to sin I over sin R. Snell's law, sin I over sin R. N is equal to the sine of 63 over the sine of 90. And if we substitute that out, we get n is equal to 1.3. Or 1.31, depending on how you've rounded it. That is the end. Well done. You've reached it, and see you in the next one.